Energy is everywhere around us. But here's the thing, energy never just disappears, it constantly transforms, transfers, and sometimes getting a bit lost along the way. Today, we'll dive into one of physics' most fundamental laws and discovering why your phone gets hot, why car brakes warm up, and why that bungee jump doesn't quite bounce back to where they started. Let's start with the basics. Think of energy like money in different bank accounts. It can be stored in various ways. It can move from one account to another. We have different energy stores. Starting with chemical energy store, like the fuel in your car or the food you ate for breakfast. There's also kinetic energy, that's the energy of movement from a speeding bullet to a gentle breeze. We have gravitational potential energy that is stored in anything above the ground level. The higher an object is, the higher its gravitational potential energy. Then we have elastic potential energy, that is the energy stored in stretched or compressed objects, rubber bands, springs, even the ground you step on. And then we have thermal energy, which sometimes we call internal energy depending on the application. That's the energy stored due to temperature. Well, here's where things get really interesting. Energy loves to move around. In a simple touch, chemical energy from the battery becomes electrical energy flowing through wires, which then becomes light energy and thermal energy. Yes, that's why your touch gets warm. When you boil water in an electric kettle, electrical energy transfers to the thermal energy store of the water and the kettle itself. The energy isn't lost, it's just changed form. The principle that rules the entire universe, which is the law of conservation of energy, that is, energy cannot be created or destroyed. Full stop. End of story. That's the law of conservation of energy. And yeah, it's more reliable than your morning alarm. Watch this ball being thrown upwards. As it rises, it slows down. Its kinetic energy is decreasing while its gravitational potential energy store increases. At the very top, it stops for a second. Maximum potential energy, zero kinetic energy, then gravity takes over and it falls. Potentially, energy converts back to kinetic energy. So the total amount of energy never changes. It just moves between different stores, chemical, kinetic, gravitational potential, elastic, and you name it. This brings us to one of the most thrilling examples of energy